Hello everyone, welcome back to ChemONotes. Today we will study Sharpless Epoxidation, which is also known as Sharpless Asymmetric Epoxidation. Today we will simplify it and stay tuned with ChemONotes for the tricks for stereochemistry of epoxidation. Do like, subscribe and hit the bell icon for more notification. So grab your notebook and let's begin with sharpless epoxidation. So let us understand sharpless asymmetric epoxidation, one of the most important reaction and one of the favorite reaction which is always asked in the exams like CET, NET, GET and JEE. Okay, so let us understand it. There is a allylic alcohol, okay, which can be converted into a epoxy alcohol. So it is a simple reaction where allylic alcohol we can convert it into epoxy alcohol. So there is a formation of epoxide on the double bond. Main thing is the catalysts which are used for this reaction. You can find that the tartrate ester is combined with titanium tetra isopropoxide and tertiary butyl hydroperoxide, that is BuOOH as an oxidizing agent. Okay, so one thing is, because it is an enantiomeric, that is addition takes place of epoxides, that's the reason why it is a very favorite reaction of the examiners and they always ask such type of questions in the exam. Now before going to the reaction, proceeding to the reaction, let us understand what is SS diethyl tartrate. Okay, so let me draw the, it is a tartaric acid where the OH groups of tartaric acid is substituted by ethyl, that is, let me draw it and show you. So SS is your S configuration, that is sinister configuration, okay, at 2 chiral carbons. So let me draw and show it to you. For example, this is your double bond O, okay, then there is double bond O and O. Now this is, we are saying that it is a, if I draw OH groups here and here acid groups, then it will be a tartaric acid. So they are saying diethyl. So instead of acid, I'll add a ethyl groups. Okay, substitute it with ethyl groups. So it will become ester. Now when it is S, that means this carbon has a S configuration. Even this carbon, chiral carbon, has a S configuration. So these two carbons, let me show it with red, both are chiral carbons. Okay, both are chiral carbons and both are having S configuration. Both are having S configuration, that is optically active. So this is your catalyst which is used. Now when this catalyst is used, we denote it by minus DET. Okay, minus DET indicates, minus indicates SS, DET is diethyl tartrate. And along with this, many a times there is CH2, Cl2, then minus 40 degrees and such combinations they give. But these combinations also you should know. With minus DET, it is your titanium tetra isopropoxide and tetrabutyl peroxide. Okay, so using these three combinations, there is a epoxidation taking place. And what is the starting material? You should always remember the starting material is allylic alcohol. Now what do you mean by allylic alcohol? The double bond, then there is one carbon, and on that adjacent carbon there is OH group. Okay, so you can see here double bond, the adjacent carbon, this is your adjacent carbon on which there is a OH group. So such uh, arrangement we call it as allylic alcohol. Okay, so on this allylic alcohol, the pi bond is going to break and there is formation of epoxide. Now what is the trick here? You have to understand that it is going to have a stereochemistry, because both these, that is SS diethyl tartarate is having a configuration. Similarly, RR diethyl tartarate will have different products. So both SS and RR are going to give you different product. Okay. So what is the how we can represent RR diethyl, that also I'll show you. And then we can begin with the reaction. Okay, to see what are the products. So here this is your R configuration. So in R configuration there are wedge OH groups. So this is your R configuration. Okay, both the chiral carbons are RR. Now when RR diethyl tartarate, which is all or it can be denoted as plus DET. Okay, now how these catalysts are going to play a role for the stereochemistry of the product, let us see. So let's see, I'll just remove this catalyst and we'll see the products. Let me remove this. Okay, student, so basically you should understand that plus DET and minus DET is going to play an important role for formation of the product and the stereochemistry. So let us see what is the products you will be getting. So SS diethyl tartarate, that is if it undergoes a psi phase, that is psi phase means left turning arrangement. Okay, there are two terms you should know, that is one is known as psi phase and other is known as re phase. Re phase indicates, psi phase indicates left turning arrangement. Okay, and re phase indicates right turning arrangement. So in the next, after finishing this, I'll tell you the trick how to remember it. So re phase and your psi phase, you can have this such type of arrangement, and there is a addition of these catalyst and they are going to give you some stereochemistry. Now whenever it is a minus DET, okay, that is it will have a psi arrangement and you will be getting a product where the product is this way. Let me show you. You will find this, that you are going to get a epoxide on a pi bond, that is this pi bond, and you are going to get a wedge, that is the epoxide ring is above the plane. Okay, above the plane, epoxide ring is above the plane for minus DET, that is psi phase or left turning arrangement. And whenever it is a re phase, that is right turning arrangement, the epoxide which will be formed using plus DET, you are going to get a epoxide ring below the plane. So you can find here I have denoted by dash and here with a wedge. Okay, so this is what is it makes make this rearrangement not a rearrangement reaction but a epoxide reaction, an important reaction, and that's the reason why these reactions are asked in the competitive exams. So let us see the trick of, and whatever is the product this is formed, these are known as epoxy alcohol. These are known as epoxy alcohol. You can find here there is a epoxide ring and there on the allylic again carbon there is OH group. Similarly here the epoxide and the OH. Okay, so here you will find this carbon which was allylic carbon is having the OH group. So there is no other difference in the starting material and the product. Only thing is the pi bond has been converted into epoxide ring. Okay, so let us go to the trick of understanding which will give you wedge and which will give you dash epoxide, that is below the plane and above the plane. Now here you can find that I have taken a allylic alcohol. Okay, let me show this. This is an allylic alcohol, and if you see the reagents on the arrow, that is plus DET and your titanium. Okay, that reagent which was used Now this is going to have, immediately after seeing the reagents on the arrow, it should click you that it is a Sharpless epoxidation. Okay, so the pi bond is going to convert into epoxide, like I have shown here that it is below the plane. Now how you will come to know that it is below the plane? There is a trick for this. What is the trick? You should remember. Let me write it. The trick is that whatever just now I told you, psi phase and re phase, correct? Psi phase and re phase. That is, you are going to have the alcohol which will be there, you are going to rearrange it as right, that is re, and psi, left. Psi is, so let me show it this, left is psi phase and re is right phase. Okay, re is right phase. So now what is the trick? What you are going to do, take the starting material and try to turn it in this way, that is anti-clockwise way, okay, in 90 degree. Let the OH come vertical, okay, it should come in the vertical way but at the top. So when you turn this by some angle, that is so as to get the OH on the top, okay, and it should be vertical, like here you can see. So if I rearrange this, what will happen? I'll show you how it is going to rearrange. If you turn this, try to rotate this molecule. Now let me show it here, because I'm going to show one table here. So it will be this way. Okay, when I turn, what will happen? Here is your OH, H, and when you turn it on the exactly this way, what is going to happen is this will come this side. Okay, this is how the arrangement you will get. So when the OH is on the left hand side, that is re side, psi side, what is going to happen? You are going to get a dash. Okay, so let me show this. What is happening? Plus DET and minus DET. Plus DET is going to give you wedge, and minus DET is going to give you dash. Okay, plus, this is minus, and so this is a simple trick which you are going to remember, that after turning it on the top, the allylic OH group, which side it is going to be there, that you have to find out. So here the alcohol group is on the left hand side, okay, that is C phase of the arrangement, psi phase of the arrangement, that is left. So if it is left and it is plus DET, left and plus DET, what is the epoxide you are going to get? A dash. So you can show here the dash OH group or the epoxide ring will be below the plane. Okay, so this way you can, this is a trick which you should remember. So I can just draw a table. So this is the table which you are going to remember for C phase and re phase of OH group. Okay, arrangement of OH group. Only thing is you are going to remember it in such a way that whenever you turn the molecule, the starting material, it should be starting given reagent, you are going to turn it on the upside down, okay, and see to it that the OH is on the top, whether it is on the left hand side or right hand side, that you are going to find out. So if OH is on the left hand side, then see the reagent of DET. If it is plus, then it will be, the epoxide will be below the plane, and if it is on the right hand side, then DET will, the epoxide will be above the plane. Okay, so here I'll write down there is wedge and dash. Similarly, wedge and dash. Okay, so this is a small trick for epoxidation of your sharpless asymmetric epoxidation. Let us see the next one. You will find this is the same, but the OH I have shown it on the left, this side. Now if you are going to again rotate it this way to bring the OH upside down, what will happen? You are going to get it, see, this way, that OH is going to be on the left hand side. OH will be on the left hand side, and here is your pi bond. Okay, this is how you will be getting after rotating it. Now once you rotate it, OH is on the left hand side, OH is on the left hand side. So what you are going to get, minus indicates the OH. If it is on the left hand side, go and again see the table which we have seen. You are going to get a wedge that is above the plane. The epoxide ring will be above the plane. Okay, so this is the simple trick which you are going to remember. So whenever you have such question, try to rotate the allylic OH group on the top by anti-clockwise way and try to find out. So let us see the next one, third one. You will find here the OH, this is the allylic OH group. Now you turn it. So when I rotate this in the same fashion, again the OH will be on the left hand side, and if you see on the arrow it is plus DET. So we are going to get a wedge, a dash epoxide, or we also call it as the epoxy alcohol, which is going to form where the epoxide ring will be below the plane. Okay, epoxy alcohol will be below the plane. Now let us go to the next one. So let us see this. You can find here is the double bond. Okay, here is the double bond, and this is your allylic alcohol. Now let me rotate it. Let me rotate it clockwise, anti-clockwise, and what you are going to get? Just try to see where the OH will go after rotating. You will find that the OH will be on the, yes, OH will be on the left hand side again. Okay, so when you are going to rotate this, and if the OH is on the left hand side, what you are going to get? You will be getting a product where, let me write it now, OH. So here you are going to get a below the plane. So for plus it is below the plane, and here it is SI ME 3 times. Okay, now the next one, again when you rotate this, again OH will be on the left hand side, so minus DET. That means what you are going to get, the product will be C10H19. Okay, and your pi bond will break, and you will get a epoxy alcohol, where you should get a what, because it is minus and OH will be on the left hand side when you rotate it. So you are going to get a what, wedge OH wedge epoxide, that means above the plane. Okay, above the plane. Similarly, let us try the next one. Next one, it is plus DET, and epoxide, again the allylic OH will go on the left hand side. So you should get what? You should get a dash epoxide, that is below the plane epoxide. Okay, very simple it is. So this is isopropyl group, and this is the epoxy alcohol you are going to get using your Sharpless asymmetric epoxidation reaction. So very easy to recall it also. Let us complete all these practice questions. Okay, so it is C8 and your OH group plus DET. So students, tell me what will be the where should the epoxide form, below the plane or above the plane? Yes. Where is the product you should get? So we are going to get here, because it is when you turn the in the anti-clockwise direction. So the OH is on the right hand side. Okay, OH will be on the right hand side and it is DET. So we are going to get here the epoxide which is above the plane. Epoxide which is above the plane. Okay, this way. Then next is again the OH. If you turn, it is already above and it is on the left hand side. Okay, it is on the left hand side having plus. So here the product what you are going to get it, because this is already, see, this is what we should get the direction. The double bond should be vertical and the allylic OH. Now already the allylic OH is on the which side? It is on the right hand side. Okay, right hand side. So what is the product you will be getting? The product which you are going to get is a benzene ring, not a benzene ring, a cyclohexene. Then there is a allylic OH. Now this cyclohexene, the pi bond is going to break and you are going to get a epoxide. You are going to get a epoxide. But when epoxide, the OH, allylic OH is on the right hand side and it is plus DET, go and see our table. We should get a wedge. We should get a wedge, that is above the plane epoxide. Above the plane epoxide. So here is how you are going to get a epoxide. Okay. Now the next last one is minus DET, and if you try to rotate this, which side the OH is going to go? When you rotate it, the OH will be on the left hand side. The OH will be on the left hand side. So if the OH is on the left hand side, after rotating it, okay, here also you, so if it is on the left hand side and minus DET means you should again get a wedge. Okay, you should get a wedge, that is above the plane. Above the plane. So here, this is how you are going to get the product. Okay, you are going to get the product this way. There is a double bond here, and this way you can solve the Sharpless epoxidation numericals or the problems which are given in the exam. They are very simple. I've told you the trick. So stay tuned with ChemONotes for more such videos, and do go and visit our playlist on ChemONotes for other videos which have been uploaded. Thank you for watching. Please subscribe, share and hit the bell icon to get the more notification of the videos which are being uploaded. Thank you.